Welcome to the NASA report. We're about to witness the launch of the Space Shuttle Discovery. Let's go over the basics of this launch.
Well, Ashley, since its first flight in 1981, the Space Shuttle has been used to extend research, repair satellites, and help with building the ISS. The goal of this mission is to test new safety and repair techniques after the Columbia disaster. Let's discuss the launch of the shuttle into space.
Of course, although I don't really understand the math involved, here are the basics I do know. The Space Shuttle is planned to launch at approximately 2:37 from the Kennedy Launch Center in Florida. And
I know who we can talk to, Dr. Denbroder.
Yeah, great idea. He's a math genius.
Well, hello everybody. So it seems I've been asked to tell you guys a little bit about the math involved in launching a space shuttle. Now, a lot of people don't realize that there's actually a lot of math involved in something like this. So first of all, you have to start out with the basic knowledge and data that goes with it. So most NASA engineers use computer modeling to figure out the basic numbers involved. So we're going to go with the time, altitude, velocity, and acceleration that changes during the launch of the space shuttle. Now, we're going to go in increments of 20 seconds throughout up to 520 seconds. Now, when they figure all this out, some stuff they have to consider are the mass of the propellant, the atmospheric pressure and density during the time of the launch, and other such weight and mass things to do with the space shuttle. And after they figure all that out, they plug into a computer in a computer model, and they figure out these numbers. So, give me a little bit to write all these things down. Okay, and now we just need to plug it into a calculator.
Okay, so now that we've plugged everything into our calculator, we need to see if all the settings are correct before we can graph it. So it looks like all the plot settings are correct, as I already did them, and the window settings appear to be correct too. But the Windows settings especially, we need to make sure that they're all correct, otherwise we might mess up our answer, we won't see the full graph. So now it does look like they're all correct, let's graph it. So looking at the graph, it's actually a very interesting graph. We know that it's not a linear graph, and we know it's not a quadratic graph because it's not a parabola. So that leaves cubic or quartic. So we want to plug in both of those and see which one it might be. And we might as well start with cubic. So simply to do this, we have to go to Calc and click on cubic regression. Now with this, we're going to calculate it, and after we get the calculations for it, we're going to plug it all in, and ultimately we're going to graph it and see if it matches what we already have. And it doesn't. So we obviously know then that this is not a cubic regression. So the next thing we want to try is a quartic regression. This one would be to the fourth power instead of the third power like cubic would be. So we're going to go back, we're going to plug in quartic instead of cubic. We're going to calculate it just like we just did. And once we've done that, we're going to plug in all the numbers and make sure they all fit. And make sure we have them all right, because if we get any wrong, the graph won't be exactly right in the way we want it to be. So now we have it all in, we're going to graph it. And it looks like it fits just right. So now that we know that this is a quartic function, and with that we can then go on and figure out the exact function for it, and ultimately take the derivative of it to figure out the more information that we need.
Okay. Now that we've figured out the graph for this function, we have to write it. So, here we go. We'll make h equal to the altitude, and I'll have t equal time. Now the reason we're going so many decimals back is that we want to make it as exact as possible. Now the numbers that I'm using I got off the calculator. It gives it for you after you are plugging the graph. Now the reason we need to figure out the function before we can go any farther is that we'll need to take the derivative of this. Now that we have the original function, we need to take the derivative of it. So, I've already worked this out on a sheet of paper, so I'll just copy it up here for you so you guys can see it. So again, we're going to have h equal to altitude and t stand for time. The derivative of it is going to give us is the relative maximum and the relative minimum. Now, to figure this out, I'm going to use my calculator. Now that we have the original function, we're taking the derivative of it, we need to take the derivative of the derivative. So, I've already figured this out as well, so I'll just write it up. Now, with this, we can plug it into our calculator and figure out the points of inflection. So, let me do that real quickly. Okay. Now that we've figured out the points of inflection, we can figure out what they exactly mean. So the points of inflection are at 122 and 450 seconds. Now this correlates with this picture right here. 122 seconds is when the solid rocket boosters fall off from the main shuttle, and at 450 seconds the external tank falls off. They fall off at this time in order to lose mass because the propellant in them is already gone. Now let's just summarize everything that we've learned today. First of all, when you find the first derivative, you find 2 points, the relative maximum and the relative minimum. Now these are the 2 points of the maximum altitude and the minimum altitude. These help them to realize when it hits the peak and when it hits the minimum. And then, when you take the second derivative of that, you can figure out the points of inflection. Now the points of inflection tell us when the two things separate from the main shuttle before it goes into orbit. The solid rocket booster at 122 seconds, and the external tank, or the ET, at 450 seconds. Using this, the scientists are able to figure out exactly when it's supposed to detach. If it doesn't detach at the right time, the space shuttle won't reach our orbit. I hope you guys have learned a little bit about how math is involved with space shuttle launches.
Oh my gosh, we've almost missed the launch.
Booster ignition and liftoff of the Discovery returning to the space station Navy